Relax and settle into a quiet moment. As you breathe slowly and comfortably, allow your mind to drift gently through ideas and possibilities, thoughts that invite curiosity without urgency. Tonight, we'll explore some intriguing concepts about the nature of reality, gently opening the door to questions that have fascinated humanity for centuries. There's no need to analyze or understand everything right away. Just relax, let your thoughts flow softly, and enjoy this calm, reflective journey. Exploring the evidence supporting the simulation theory, the idea that our universe might be a sophisticated simulation has fascinated thinkers, scientists, and philosophers for decades. From ancient philosophical musings to cutting-edge technological discussions, the simulation hypothesis posits that reality as we perceive it could be an artificial construct created by an advanced civilization or entity. While at first glance this notion might seem like science fiction, a growing body of scientific and philosophical evidence suggests that there are compelling reasons to consider the possibility seriously. This essay explores the key pieces of evidence and reasoning that support the simulation hypothesis, examining computational limits, physical phenomena, quantum mechanics, and more. 1. The conceptual foundation of the simulation hypothesis. Before delving into the evidence, it's important to understand what the simulation hypothesis entails. Popularized by philosopher Nick Bostrom in 2003, the hypothesis suggests that one of the following propositions is likely to be true. 1. Human civilization will go extinct before reaching a post-human stage capable of creating realistic ancestor simulations. Second, post-human civilizations are not interested in running ancestor simulations. 3. We are almost certainly living in a computer simulation created by an advanced civilization. If the first two propositions are unlikely, then the third becomes the most plausible. The idea hinges on the assumption that sufficiently advanced civilizations could harness immense computational power to simulate conscious beings within a virtual universe. 2. The limitations of physical computation. A clue from nature. One of the strongest lines of reasoning supporting the simulation theory comes from the recognition of physical limits on computation. According to physics, the universe itself operates under constraints that resemble computational limits. A. The Bekenstein bound and information density. The Bekenstein bound states that there is a maximum amount of information, measured in bits, that can be contained within a finite region of space, possessing a finite amount of energy. This limit implies that the universe's information content is finite, which aligns with the idea that the universe might be a computational system with finite resources, much like a simulation. The holographic principle. The holographic principle, derived from black hole thermodynamics and string theory, suggests that all the information contained within a volume of space can be represented on its boundary surface. This principle hints that our universe might be a projection of information encoded on a lower dimensional boundary, similar to how a computer simulation could be rendered in 2 dimensions, but perceive 3-dimensional space. C. Computational limits and the universe's processing power. Physicist Seth Lloyd estimates that the observable universe can perform around 10 to the power of 120 operations per second. This finite computational capacity indicates that the universe is akin to a cosmic computer and supports the idea that the universe itself might be a simulation running on some underlying computational substrate. 3. Quantum mechanics and the nature of reality. Quantum phenomena have often been cited as potential evidence for a simulated universe due to their peculiar and non-intuitive properties. A wave function, collapse and quantum indeterminacy. In quantum mechanics, particles exist in a superposition of states until measured, at which point the wave function collapses to a definite state. This observer-dependent collapse can be interpreted as a form of rendering only the observed portions of the universe, akin to how graphics are rendered in real time in a video game only when in view. This suggests that the universe might be a computational simulation that calculates reality on demand. B. The fine-tuning of physical constants. The universe's physical constants are precisely tuned to allow life and matter as we know it. The improbability of these constants aligning so perfectly has led some to suggest that this could be evidence of a designed or programmed universe, similar to parameters set in a simulation environment. C. The discrete nature of space and time. Quantum mechanics implies that space and time are quantized at the smallest scales, with the Planck length and Planck time representing the smallest meaningful units. This discreteness resembles pixels or voxels in digital graphics, implying that space-time might be a form of digital information. 4. The simulation hypothesis and cosmological phenomena. Several cosmological observations have been argued to align with the simulation hypothesis. A. The fine structure constant. The fine structure constant, Bose 1/137, governs electromagnetic interactions. Its precise value is critical for the stability of atoms. The fact that this constant falls within a narrow range might suggest a programmed universe optimized for complexity. B. Cosmic microwave background, CMB anomalies. The CMB, the afterglow of the Big Bang, contains subtle anomalies and fluctuations. Some researchers propose that these irregularities could be artifacts or rendering artifacts of a simulated universe, similar to glitches or compression artifacts in digital media. C. The universe's mathematical nature physicist Max Tegmark proposed that the universe is a mathematical structure. If reality is fundamentally mathematical, it could be indicative of a simulation based on mathematical code. 5. The appearance of glitches and anomalies. Some researchers point to specific anomalies in physical data that resemble glitches in digital simulations. A. The horizon problem and large-scale structure. The uniform temperature of the universe across vast distances, known as the horizon problem, is explained by cosmic inflation. However, some argue that certain large-scale structures and temperature fluctuations could be artifacts of a simulation's rendering process. The cold spot in the CMB. The cold spot is an unusually large and cold region in the CMB. Its existence has puzzled cosmologists. Some suggest it could be a rendering artifact or a sign of the universe's artificial origin. C. Quantum entanglement and non-locality. Quantum entanglement involves particles instantaneously affecting each other regardless of distance. This non-locality defies classical physics, but could be explained if the universe is a simulation employing non-local algorithms to maintain coherence across the simulated space-time. 6. The evolution of computing power and future possibilities. The rapid advancement of technology lends credibility to the idea that future civilizations could develop the computational capacity needed to run detailed simulations. A. Moore's law and beyond. Historically, computing power has doubled roughly every 2 years. Although physical limits threaten to slow this trend, emerging technologies like quantum computing and neuromorphic chips promise exponential increases in processing power. The feasibility of running ancestor simulations. If a civilization can simulate entire universes with conscious entities, it is plausible that our universe is one such simulation. The concept of ancestor simulations suggests that future humans might run detailed simulations of their ancestors' past, possibly including US.C. The simulation hypothesis as a testable hypothesis. While difficult, some scientists argue that certain predictions derived from the simulation hypothesis could be tested. For example, detecting computational artifacts, limits on the resolution of space-time, or anomalies in cosmic rays could provide evidence. 7. Philosophical and scientific implications. The evidence discussed raises profound questions about the nature of reality and our place in the universe. A. The nature of consciousness. If we are in a simulation, what does that imply about consciousness? Are our subjective experiences emergent phenomena within the simulation, or are they part of the programming? B. Ethical considerations. Creating conscious beings within a simulation raises ethical questions about the responsibilities of the creators and the moral status of simulated entities. C. The reality of the simulation. If our universe is a simulation, it challenges our understanding of reality, suggesting that what we perceive as physical laws are merely part of the simulation's code. 8. Counter-arguments and skepticism. While the evidence is intriguing, it's essential to consider counter-arguments. Lack of direct evidence, no definitive proof exists yet that confirms we are in a simulation. Cognitive biases, human tendency to see patterns, might lead us to interpret natural phenomena as signs of simulation. Technological limitations. Some argue that the computational requirements for simulating an entire universe are beyond conceivable limits. The balance of possibility. The evidence supporting the simulation hypothesis is compelling, rooted in the fundamental laws of physics, quantum mechanics, cosmological observations, and the rapid growth of computational technology. While direct proof remains elusive, the convergence of these lines of reasoning makes the hypothesis a serious scientific and philosophical consideration. In the end, whether or not we are living in a simulation, contemplating this possibility expands our understanding of reality, pushes the boundaries of science, and inspires us to explore the profound mysteries of existence. As our technology advances and our understanding deepens, future discoveries may bring us closer to answering whether our universe is truly real or a magnificent illusion crafted by an advanced consciousness.